Hello. This is Colin Reed, and this is the final video for my final project of CPE 100. It's PostLab 13 technically, and this is my design for the elevator project. So in this project, I just want to explain a little bit of my design first. I'm going to go more in depth after I show it, but I did do the modular design, so I designed the floors. I designed the floor kind of controller first and made sure that everything was working there, and then I designed the actual door, so it kind of analyzes when the door is open and closed, and it also controls the busy light and LED 9. I designed those all separately and then combined them, and everything's working good now. Also, I do want to say that I changed a few of the assignments for the pins, because this side of my board doesn't work correctly. It hasn't worked since the beginning of class. So I assigned my BCD floor selectors to 9, 8, 7. So these are going to be technically 4, 2, and 1. Right there is 4, 2, 1. And then I still have switch number 3 as the fire selector. And everything else is as it should be. So, key 3 is the confirm floor button, and then key 0 is the actual close door button. So this will close the door, and this will confirm the floor. You have to confirm the floor before you travel, otherwise it'll just open and close the door, or close and open the door, I should say, because you're already on the floor you want to be on. So I'm just going to show a quick little example of it working. I'll do from 0 to 7, just to show it go all the way up to 7 first. So first you confirm the floor with this key, press it down. Nothing happens because it's just confirming the floor. And then when you want to go to that floor, you press this button down. The clock will start, 4 ticks for the door to close, and then every floor is 1 clock cycle, and 4 for it to open again. So that's kind of just, you can go to any floor you want. If I want to go to floor 4, confirm floor, press the door button, closes the door, close, travels. When I get to the floor I want, opens the door again. It looks simple, but I did struggle quite a bit with the design. More so combining the design rather than actually creating the individual ones, because I managed to get them working individually, but when I combined them, I struggled with finding the correct kind of outputs and inputs to make them connected, but in the end I did manage to figure it out. So if I want to go back to floor 0, confirm floor, and hold this, so we'll just do that, then the door will open, and I will show, so if I was to not confirm the floor and I was to just hit a button, if I was to just do that, it would close the door and open it since I'm already there. And even if I was to turn the floor into 7, if I don't hit the confirm floor, it'll still do the same thing. The reason I did that is because, you have to actually confirm the floor. This is connected to a 3-bit memory, so I have the 3 bits here and this to confirm. And then I have technically they're connected to another 3-bit memory that actually lets them go to my floor selector controller. But in order to send it through, I set the door button as my clock signal to that 3-bit memory, so that first it'll always store it no matter what. So if I was to select it now, I can still change the floor if I want to change it to 4 first, and then select it. It'll go to 4 instead of 7, because that's what I selected. So you can change the floor if you selected the wrong one before you have to close the door. And then this one I struggled the most with, actually, the busy light. For some reason I couldn't figure out why it kept turning on for no reason. So eventually I did find out that I had to essentially, whenever the door is closed, the busy light's on anyway. So if the door is closed, so if it's traveling up floors, the door is going to be closed. If it's just closed after I travel the floors, then it is supposed to be blinking still. And then I set the input of my door button to a D flip-flop, and then I cycled the Q back into the D so that it would keep going through infinitely. but then I set it to when the door ends up closing, it would actually reset the D flip-flop because I set the door close signal to the clear N. So now that whenever, so I'll show it again, just so I have it. So when this signal, when this signal is blinking right here and closes, that's, you know, it turns to that. So hang on. This right here is going up, 0, and then it changed to C after it got the signal because it reset the open door. And now it's at 7. And finally, the last thing I really have to show for my design is the fire switch on switch number 3. So I confirm floor 0, and hit the button, closes the door, and let's say there's a fire now on floor 3. Immediately clears. I set the switch to immediately clear the floor entry for this so that it'll reset, and then I have it stored so that the output of my up-down counter goes into another 3-bit memory connected to the fire switch, so that it stores whatever floor the person's at currently into that 3-bit memory, and then it'll input that immediately into the it'll automatically input that into the controller. I have it set to OR switches, and so that when it is cleared, it will automatically take in this new value rather than the value that was already stored at this. And while you're on this floor, if I was to try to switch levels, you know, you can still open and close the door, but if you're in a fire, you shouldn't be doing that anyway. So it opens and closes it automatically. You can't actually travel floors or anything. So, you know, it's still, you know, you're still stuck on the floor, so you still have to leave because there's a fire, obviously. If I turn the switch off and try to change it, you still can't change floors. The fire switch is set to completely turn off all actions, no matter what. Even if you flip this fire switch off, in the directions it did say that after the fire switch is flipped, nothing can be done. So I can't change floors. You're not allowed to change floors, is what it said in the directions. So all the other stuff doesn't work. So if I wanted to redo this now, since the fire switch was flipped, I have to completely reprogram it in Quartus. And I will show that as well, actually, while I'm here. So that is my modular design for the for my app final project. So this is the confirmed floor that I was talking about. So when you initially hit it, that's where the floor number is saved. And then in here, in my elevator floor, I should have pulled this up before, my bad. But in the elevator floor program, where is that? Elevator floor. Sorry, probably should have had this pulled up. There you go. So elevator floor, this is the 3-bit memory I was talking about, the fire switch. So the signal from the first confirmed floor is going to go into this. And then, as you saw in the previous one, this confirmed floor, as in actually the confirmed floor button, it's connected to the closed door button. And then it'll get sent to this OR switch. And since this is set to 0 right now, since there's no input, it'll just clear through the ORs and get sent right to the 3-bit comparator. This comparator is, it was a kind of a basic design, but I'll show that in a minute as well. So as you can see, this is also my design right here. This is my up-down counter that I made. I made this before I realized there was one built into Quartus, but I don't mind that because I like this design and how it came out. I have my clock signal connected to the equal button and then a NOR, so that it'll only activate when they're both 0. And I kind of had to experiment with this a lot. I had tested a lot of different logic gates because they were causing a bunch of errors, but this ended up being the correct gate to use. And then it'll get sent through. If it's greater than, it'll get sent up here. And I have it set to a not, so if it is 0, it'll go down here. There was originally a less than output, but I decided to leave it out because it wasn't really necessary. And it kind of complicated my design more rather than just doing this, because this is basically saying, oh, not equals, or not greater than, excuse me. And it'll get sent through here, and then this is the BCD. Let me pull up my 3-bit comparator to show that. I'm gonna have all my designs placed in the report anyway, but I just wanted to show them, just to go through it. So this looks kind of complicated, but essentially these are the 3 inputs that the user puts in, and this is what they're comparing it to. So you take the knots, It's a little weird. I had to look up videos to learn how to do this because I had no idea even how to use a comparator, but it was my first thought to be like, oh, if this input is less than, you know, then I'll change floors, but I had to learn how to do this from a video. And then it'll compare all the individual, so it compares this one, let's say A0, and then it gets compared to B0. You know, and this is the equal output, and that actually gets sent to the greater than output. And then as you saw in my design, I also had a 3-bit memory that I created. It's a simple, it's not much to show on it because it's kind of just what we've done in the past, but I created a 3-bit rather than a 4-bit. So there's that. Really simple. Confirm floor, and I set this clear. I set this specifically for the fire switch, you know. I didn't need it for any of the other ones, so a lot of them don't even have an input here. But those are all set there. Very simple design with DFFs. And then, let's see, I could show my final modular design, which is the door. This one was probably what I struggled the most with, more so with the busy than anything, like I said. So, kind of complicated, but I decided to use shift registers instead of the counters for this, because I kind of found that it just worked out better. It'll just take it and then it'll output it. This looks, I know this looks really complicated, but here's the door button. It goes in here. It'll take, once this and the clear switch, the clear I set equal to, or I set it as the equal because I don't want you to be able to change doors unless it is equal. So that has to be an input. And then you'll go through the shift register and it'll be set to 1. Then it'll change the C block to 1. It'll set that equal to 1 and then close this as 0. I'm not going to show these just because they're basic. It's just an input led to 4 outputs. And then I just kind of coded them to be the correct hex signals. And right here, it's the ands so that the ones that they're shared can actually be displayed correctly. And finally, this is the main thing I wanted to show, was my busy signal. So it takes the door input, like I said, and it goes through this OR, and it goes through just a regular D flip-flop, and the output of this is sent back around so that either or, you know, if they were to press it again, it would just kind of keep cycling until this is closed. Since clear ends need to be 1 for the value to be saved, I have it set to not, so that as soon as it is 1, it's 0, and it'll clear this data, and then it gets sent to this AND. This AND is connected to the clock signal, just a basic clock signal. I do have specific clock signals for each, just so that it'll kind of read the output. So this one is connected to Q0, or yeah, wait. Oh, no, sorry, Q1. So the output of this shift register for clear, because it'll go through here and it gets connected. And this one's connected to the output of Q because it goes down and around. Anyway, sorry. It's connected to the clear end there, or the clock there. Boom. And then it's also connected to the Q0 so that when it is closed, it'll always show. No matter what, if the door is closed, it'll always show. And I think that is pretty much it. It's turned out to be a little bit longer than a video than I thought. But I don't really have anything else to show. Everything else is good. All right, well, I think that is all. Thank you so much for helping this semester, and that will be all. Adios.